Okay, we will continue with question number 20. This is also a question that appeared in an exam some years ago. It's not logical that two different curves cut each other because, okay, we saw this some equations ago, because more is better than less, and because of the transitivity property or the preference theory of the consumer. Okay, so the correct one is D. The decreasing marginal utility is not correct because, well, with perfect substitute, these properties is also hold. We can't cut the two different curves that are straight lines as in perfect substitute, and it's not verified, the decreasing marginal utility condition. So the correct one is D. Okay, now 21, also an exam question. If X is an inferior good and the price of X increases, okay, I told you this type of questions, they are very appropriate for the table I give you. Okay, so the substitution effect will induce the consumer to buy more from good X. No. Inferior good, the substitution effect, as in all of the goods except the perfect complement, the substitution effect is negative. So with the price of X, when the price of X increases, the consumer will consume less from good X due to the substitution effect. So B is also false. C, the substitution effect will induce the consumer to buy less from good X, and the income effect will induce the consumer to buy more from good X. Correct. So I told you, this type of questions with such a table are very easy. Yeah? Okay, the substitution effect will induce the consumer to buy less from good X, and the income effect will induce the consumer to buy less from good X. No, that's false. Okay. Well, the signs of these effects are not very easy to calculate and so on. We don't do it in our micro, but we should understand them. Okay. The signs are called like this because of this. Okay. And be careful, because you know what happens in your subject, okay, at the university. As the assumption is the price of good X increases, then okay, the sign of effect is the same as the sign of the direction of the variation of the quantity. Okay, but be careful. If the sign of the variation of Px is negative, I mean, if the price of X decreases, then the sign of effect will interpret like the opposite. Okay, that's why, as I told you when I explained this correctly, this effect I consider as an assumption an increase of the price of good X. Okay, so be very careful with this. Maybe in other videos after the summer I could explain some of this stuff as theory. Okay, but now I don't have enough time. Patrick will live for 2 periods. His income in period 1 is 300, while in period 2 he expects to earn 200. If his intertemporal preferences can be written as this, so they are Cobb-Douglas, and the market interest rate is 5%, so R is 0.005, then what? Okay, we should do the exercise. Okay, now we have sorry, I didn't read the possible answers. He prefers the consumption in the second period rather than the consumption in the first period. Yes, that's true, because we know that this Cobb-Douglas type functions tell me in this case that 1/3, 1 divided by the sum of the exponents, 1/3 of the income of Patrick will be consumed in period 1 and 2/3 in period 2. So we could say that Patrick likes more the consumption in period 2. So maybe he should be a saver. So maybe C should be true, and then all of the above. Anyway, sorry, we will do the exercise. So remind, we have a utility function like this. The budget constraint is 1 plus R times C1 plus C2 equal to 1 plus R times the initial, the income in period 1 plus the income in period 2. This comes from finance. Now, we act as usual for a maximization, utility maximization problem. We equalize the MRS in absolute value to the price ratio, and we write the budget constraint. Because this is a Cobb-Douglas type utility function, and we know that a tangent solution exists. Okay, so the derivative of this with respect to C1 is C2 squared. The derivative with respect to C2 is 2 C1 C2, equal to the price ratio. The price of C1 is, 1.05, and the price of good 2, the price of consumption in period 2 is 1. So this is the first equation. If I cancel this square with C2, I have C2 divided by 2C1, and if I carry this 2 to the right hand side, I have C2, and C1 also, C2 equal to 2.1 times C1. Okay, these two factors, 2C1, go to the right hand side. If I substitute this condition on the budget constraint, I find that 1.05 C1 times this, times 2.1 times C1 is equal to, this is 515, and if I isolate C1, we find 163.49, and then with this, we multiply it by 2.1, and we get 2.1 times 163, so 343.33. That I think it was number B, or answer B. So the appropriate answer is D. And take care that as the income in period 1 is this is a mistake. Income in period 1 is 300. Anyway, income in period 1 is less, consumption, in period 1 is less than his income, that is 300, so he's a saver. Here it should say 300. Okay. Another exam question. In the case of an inferior good, and again the table. In the case of an inferior good, the substitution effect is always negative. Yes, as in all the goods except the perfect complements, and the perfect complements, if I remember correctly, they are normal, not inferior. The income effect will oppose the substitution effect. Yes, of course. The substitution effect and the income effect will have the same sign. No. The marginal utility is increasing. It doesn't mind. So, for me, the answer here, in my opinion, is A and B are correct. Why do I mark B? Because as my students, as you know, there is there's a mistake, yeah, in the university when they teach this, because okay, they say that substitution effect is positive, yeah. Okay, as I tell you in my classes, you can take a look at the variant, the book, and you can see that the substitution effect is negative. So the correct one for me is A and B, but I mark B for your exam. Okay. Now another exam question: is it possible for a utility maximizing consumer to buy two goods so that the marginal utility per monetary unit spent is not equal for the two goods? This is a very beautiful question. Okay. Yes. Yes, it could happen. It could happen. For example, in perfect substitute, yeah, we have here the maximum, and the MRS is the slope of these blue indifference curves is different from the price ratio. Okay, and if that's different, if the MRS is different to the price ratio, then the per monetary unit spent, sorry, the marginal utility per monetary unit spent is different for both goods, as I explained you some questions before. Okay, so this is correct, but are there more goods where this happens? Yes, be careful. When we have very important utility functions, when we have quasi-linears, we could have the same consequences. Okay, we could have a point where the marginal utility of good X divided by the price of good X is not equal to the marginal utility of good Y divided by the price of good Y. Okay, so here the correct one is A. Okay, I usually comment this question in class in the academy because I think that this is a very beautiful question. Okay, so if you have any question, you can ask me. 25th. A rational consumer is given 5 pizzas and 10 bananas. The prices are 2 and 1 respectively. Okay, the price of each pizza then is 2. The price of each banana is 1. Sorry. If you offer him 10 euros for his bananas, the consumer will be better off. Maybe no. Suppose that this consumer that is given these goods, okay? Suppose that he doesn't like bananas. If he doesn't like bananas, he will say, okay, thank you for these 10 euros. I will buy, for example, another 5 pizzas with these 10 euros, and he will be better off. Okay, so be careful. Okay? He will be better off. But suppose that the consumer likes bananas a lot. If he is offered 10 euros for his bananas, he will say, okay, no, I don't want that money. Okay, so the consumer will be the same, would be equally happy, no? Let's say. So be careful. The consumer will not be worse off. Okay, and this is the correct answer. As I told you many times when we see each other, this is very important tool. No, I think we should construct this kind of thinking, yeah, in our head. Okay, I think this is one of the most important things in micro. So here I wrote you those situations that I explained you. Yeah, if I decide to change, it's because I'm better off. But if I don't decide to change, to change is because I stay the same. So B is the correct answer. Now, 26th. Esther has Cobb-Douglas preferences over goods X and Y. Okay, for example, like this. Whose prices are 3 and 4 respectively. What will be MRS at the optimal bundle? Okay, we calculate the MRS, and that's very easy. Yeah? At the optimal bundle, the MRS is equal to the price ratio because the tangency condition is verified in the Cobb-Douglas case. So the MRS is negative minus 3 divided by 4 because the prices are 3 and 4. Now, sorry, that's all. So minus 0.75. Okay. The point here is that the question tells me at the optimal bundle. Okay, and at the optimal bundle, the MRS is this. This is another beautiful question. We don't need to calculate the MRS, so this that I gave you here was not necessary. Okay. Well, 27. Agatha has the utility function y divided by x. The commodity y is a good for her because the marginal utility will be positive. The more of y she consumes, the better she is, the better she feels. And if commodity x increases, if Agatha increases her consumption of good x, then the fraction will be lower. So x is a bad for her. Yeah, I made you here the marginal utilities, so it's more correctly, but I wanted to learn how to do it just by analyzing where this y and x are in the function. Okay, so we said that x is a bad and y is a good, so it should be D. Yeah, it should be D. Y is a good, D is a bad. Yeah, perfect. Now, 28th. The curve relating the income with the quantity demanded for a selling good is called, well, I told you before, it's called angle curve. Yeah. And the one relating the price of the good with its demand is called the demand curve. Okay, so this is a easy question, but of course interesting. We should know this. Now, 29th. A consumer's utility function is this one. These are complements, but if we look at the components, they are not the typical components as 3x, 2y, or x, y, or x, 5y. Okay, so we have to be careful, but the exercise is done the same. Okay, and the price of good x are px equal to 2 and py equal to 3. If her income is 42, she will demand exactly how much. Okay, we do the exercise. This is the problem of the consumer. Now, as I told you before, we equalize these two components, 2x plus y equal to x plus 3y, and on the other hand, the budget constraint must be satisfied. Then, for example, from the first equation, we carry x to the left, and we have x. Then we carry y to the right hand side, we have 2y. And we carry this equation to the second one, and by substituting, we have 2 times 2y, so 4y plus 3y equal to 42. Then y equal to 6. Yeah, and if y is equal to 6, we look for x we go backwards here, and we find here x. So x is twice y, so 12. Okay, we then should mark here, okay, D. Perfect. The 30th, another exam question. Then suppose x1 and x2 are perfect substitutes and the MRS is -1. If income is M and prices satisfy that P1 is lower than P2, then which of the following characterizes the optimal consumption bundle? Well, this is very easy. If the MRS is -1, that tells me that x1 and x2 are equally desirable, yeah, equally likely. So the substitution the consumer makes from them is 1-to-1. So if he or she substitute them 1-to-1 and good 2 is more expensive than good 1, so we only will consume from good 1. So how much? We know that M divided by Px or P1 is the intersection point at the x-axis, and so this is the correct one. Clearly, yeah, clearly. This is the explanation, but I think it's not necessary here. I will leave you here some seconds to look at it, but well, not necessary. It's very easy.